It's a pleasure to have here with us António Onofre, a good friend and collaborator from the University of Minho, particle physicist converted into a gravitational wave physicist now, in the second life. So, António, please,
yes.
Thank you very much for being here.
Thank you very much for the invitation, Carlos. This was really a nice surprise and a pleasure to be here again. This is the things that I'm going to share with you guys are the fundamental discussions that we had. And actually, starting from small things, we actually build something that it's getting some structure. So at the end of the day, I should speak about 3 things, but I didn't have time. So I'm just going to pop up the slides among events, okay? But actually, there is something which is very important to us, which is the students and the projects that we will do together, that we need to do together. The students, why? Because Graph has been a huge structural help for the students that either come to Graph or are supervised by Graph people. So I had actually a picture from Marco, but I thought that if I would show a picture from Marco, it would be embarrassing. So I'm not going to do that. So, but actually, I even wanted to show the message that I sent you. Okay, talk to Carlos, you know, many years ago. But I'm not going to share this. Okay? But at the end of the day, the message is there. It's still funny to me that when we started these first steps, actually it allowed us to structure a bit more our relation and the construction that we are doing, even at Minho. And I'm going to show you some slides also of the things that happen at Minho because of this. Okay, so let's start. So, should point somewhere?
The other one,
No. Down. Okay. So the first time that we had the first contact related to this physics was an invitation that Carlos gave me back to 2015. It was actually this event that actually, 100 years of strong gravity, 5 years of Graph. And you remember that my talk was so long that I think I killed everyone. So eventually, but I showed the physics case from the particle physics point of view. Okay? I could never think that 10 years later, we would end up with a proposal for this meeting. Okay, that's the thing that I want to discuss. For the future, this is related for the future. Now, later on in 2018, there was a student, once again, João Diniz, that actually was here presenting something, some time ago, that actually pushed me to really go to this field. He was telling me, okay, I've been in contact with these people and I heard some talks of Carlos and stuff like this. You need to start thinking about this. I'm a particle physicist. What am I going to do in astrophysics? I have nothing to do there. But he was so pushy, this guy, that actually I said, okay, I will have a look. So in 2019, between 18 and 19, I decided that if students are interested, maybe it's the right time to create a structure in Minho. So this was the advice. So I decided, okay, I created this laboratory, which in order to avoid any antibodies and stuff like this, I kept it quiet. Because I just wanted to have fun on doing this kind of physics. I wanted to search this kind of physics, I wanted to have my own path, and I decided, okay, it makes sense that we build something which is in the bridge between particle physics and astrophysics. So this means that actually this part is not very easy because the funding agencies, they look at us like corporate people. So what are these guys doing in between these two fields? But actually, I think these times are changing. That's my feeling, is that these people are looking into us like, okay, let's see what happens in the future. Then we decided to have common events. And this was the first time that we had the chance to really dedicate some focus on the compact objects connected with machine learning, and I miss those functions. This is something that we needed to really pick once again, and the sole reason for me is that if we only discuss machine learning, the problem becomes non-physics. And this is a problem to me because I like to think. So I see machine learning as a tool. I'm a physicist. So I use a tool. I don't question the screwdriver that I use in order to screw. You know, that's how I see machine learning. Machine learning is a screwdriver. And I'm not going to create something on screwdrivers. I mean, it doesn't make sense in my brain. So we need to come back to feed the physics to these events, because I actually miss the connection between these two worlds, because to me they are very, although we need the tools, we need much more to discuss the physics. That's the thing that we actually, that's a bit my worry, you know. I understand that we actually were very successful because we had this hands-on session that were extremely successful, and we know how to handle the tools. It's just we know what the tools are. But actually, if I know how to handle the tool, I know I'm able to solve a physical problem. And that's the thing that I think we should concentrate on. I mean, although the tools are good, if I can apply them, it's even better. So we actually went to Valencia for the second edition, and this is a picture. You can actually recognize people. This is Antonio. He's there. This is Carlos. This is Tony. And I don't know if there is someone else that we know. Okay.
You.
Yeah. This is it. Okay. This is Nico. But actually, you see, the good thing about this is that we had a lot of time to discuss several aspects of physics. And I think this is very interesting. This is one of the pictures that I'm going to show. Okay. I think this is but actually, I miss a bit the continuation of these workshops. And so probably one of the things that I would like to challenge people is that maybe we have done these workshops, and maybe, I don't know, me, Antonio, and Carlos, we should think about, I don't know, during 2026 or the year after, I don't know, to really start this once again. And the worry is that to feed these workshops with physics, but a good level of physics. You know, it's not only the tools. You should see that there is a very interesting perspective, because when we start looking into collaborations with people that belong, like Jose from the University of Valencia, they bring to the discussions a lot of the tools that they use in machine learning. So from this side, we are more or less protected from the quality of the tools. But sometimes I miss very much this discussion on it. That's the thing that. And then everything popped up to something that happened at CERN last month. I need to tell about this. Okay. So this was something that happened because of this. Okay. These guys, I like to show these. These guys decided, okay, I have some boson stars. The boson stars can collide, produce gravitational waves, and at the end of the day, they actually look like the signals that we have already. And actually, when we compare these solutions, they come up with something for a particle, experimental particle physicist. This is a fantastic game. It's this bump. It's a bump. But this bump is not consistent with zero, at least to 5 sigma. You see? And that's a major goal for us, because at the energy, we cannot fix energy scales. But if we have information from some energy scales, this is quite interesting. But then the objects, and Carlos can tell about these objects much better than this. They actually are composed of new radiators, because if this is not consistent with zero, this means that I have no knowledge of any other boson that has a mass like this. There is no either the photon, and then that's it, and all the other ones from the standard model are completely far away from zero. So if this exists, it must be. And the question now that we raised was, can we actually test this at the LHC? And the funny thing is that probably we can, not reconstruct the mass, because the mass is very small, but actually use spin physics. So, and this is the old total quantum angular momentum, is that if you have something with spin that you don't see, because you cannot see, because it's a mediator of that matter or something like this, but it's present on your events, the angular distributions of the things that you see, they will change. Especially if it's spin 0, spin 1, and and we see this change. It just happens that we have some stresses between our data and our expectation from it. And last year, CMS published a 5 sigma effect on some discrepancy between the top quark data together when put it against the models. And people are thinking about, okay, there is a bound state between the top quarks and this bound state. I'm crossing 10 minutes. Is 15? Okay, cool.
So,
but the bottom line is the following: is that we have some stresses between the data and the predictions. And actually, even if we take into account the presence of this bound state, it's not enough to describe the effect that we are seeing from both experiments. Because Atlas has published this year the 5 sigma effect as well. So the effect is there. And the idea is that, okay, I convinced the conveners that it would be nice to have this workshop to see if this piece that is missing is a potential candidate from these mediators. Okay? So, my conclusion. It's very simple. I think we should dedicate some time to really build this strong collaboration, because actually it has been crucial for us. The number of students that we are involving in the game is increasing. The topics that we are addressing is increasing as well. So at the end of the day, I think that we should really go through this path with all the difficulties that we had, because the only way that we can supervise the students in this kind of field in Minho is through Antonio, and there is only one person. I mean, you cannot supervise 10 students, and we will need the help of you guys in order to really consolidate this game. But at the end of the day, I think we should have some future common projects, and the one that I'm proposing now is that one. It's to continue the discussion that we started. I'm going to spend 6 months of my life next year at CERN, and the conveners of the Atlas experiment is supporting this kind of initiative, so we need to discuss, and they want to see more things happening in terms of astrophysics versus the particle physics discussion. So that is the message. Then,
thank you very much, Antonio. So it's always refreshing to hear your enthusiasm. And let's hope that something will happen. Okay? Thank you so much. So I think